So now let's talk about this main sensor that has these applications, which we said that it's called the load cell. This is a typical load cell that comes in different shapes and sizes, depends on the application. So we'll talk about this one in specific because we have it and we will do the demonstration on this specific load cell. So basically you can see here some white material covering something beneath it here in both sides, and there are four wires, black, red, green and white. So why these four wires, and what is there, what is covered under this white material? Okay, so if we have a closer look to the load cell, actually what we have here is four strain gauges, two on top and two on bottom. So this is what has been covered. Now when a force is applied, these strain gauges, some of them will have a compression force, some of them will have a tensile force, so some of them will have an increase in the resistance and some of them will have a decrease in the resistance. So the change or the force that we apply is converted into a change in the resistance of the strain gauges. Does this remind us of something? Of course, this reminds us of using the Wheatstone bridge that we used in the previous videos in the strain gauges. And actually, that is what's happening here. Those four strain gauges are connected in a Wheatstone bridge configuration, and whatever we learned in the Wheatstone bridge is also applied here. So if R1 equal to R2, your V out will be almost equal to 0, and if they are not, then you will have here an output voltage. And the arrangement of the sensors are done in such a way that R3 and R2 will either both of them increase or decrease, and the opposite will happen to R1 and R4. Meaning, I cannot have R1, R4 increases and the same time R3 and R2 increases because they will cancel each other. So one of them will increase and the other will decrease. So let's have a small demonstration here. This is my load cell, same one, connected. So we have the red and the black wires are connected to the 5-volt DC, and then the green and the white is where I measure the voltage. So here I don't apply any forces, and you can see here we have around minus 0.35 millivolt. Now when I start to apply a force on my load cell, so what will happen here to the voltage? Look, now the voltage starts to increase. So this is basically the load cell. We are converting the force into a change in the voltage using the Wheatstone bridge, which has the strain gauges connected to it.